All right, so as you guys can see, I've entered the Desmos activity that you had to complete by this morning. And I'm just going to give you some tips for solving some of these and walk through a couple of the solutions of some of the problems that were answered incorrectly. So one of the ideas that I just want to pass along to you is as you're going through trying to solve for a variable in a picture like this, you want to sort of, in your head or on the paper, make it look like those parallel lines cut by a transversal that we've seen so often. So, for example, this parallel line ends here. Maybe I want to extend that and extend this one to show that I've got those two parallel lines that really do go on forever. And then I'm going to extend that transversal there too. And now it's a little bit more apparent that I've got all of these angles, which I could label, and I think it's helpful generally to do this. So now I've got these angles labeled, and it starts to become a little bit easier to see where my alternate interior angles would be, or my same side exterior angles, or whatever relationship I'm trying to point out here. So this 35-degree angle has a lot of angle pair relationships in this picture that I could point out right now, but I guess the one that I'll point out here is that angle 3 would be considered an alternate interior angle with angle 35. So I would be able to say that angle 3 has to also have a measure of 35 degrees because they're alternate interior angles, so they're congruent, therefore they have the same measure. Now, based on that conclusion, I can take a look at D and how that relationship has to exist with angle 3. Those two angles form a linear pair. So now what I can do is I can say the measure of angle D plus 35 has to equal 180 because those angles form a linear pair. And now when I subtract 35 from both sides, I end up with the measure of angle D equaling 145 degrees. So I'm just going to go ahead and try out my answer there, 145, and I'm correct. All right, let's take a look at another one. We'll do this one here together. All right, so here I see two parallel lines, and now the angle that I'm being asked to solve for is not adjacent to any of the angles on those parallel lines. So what I'm going to do here is use a trick that I think will be useful, and I'm going to draw in a third parallel line. So assume that this line is also parallel to those other two lines. When I do that, that's going to create a set of angles that we can use to help us solve for h. So I've just taken h and split it into two pieces. I've said that the measure of angle h is equal to the measure of angle 1 plus the measure of angle 3. So now I'm just going to set about trying to find out what the measure of angle 1 and the measure of angle 3 would be. Let's take a look at angle 1. So I'm going to do what I did in that last problem and just extend this transversal. That's not great. Maybe to there and there. Okay, that's all one line, assume, even though it doesn't look quite perfect. And then I could extend that parallel line there. And so what that does is it creates a whole set of angles. Right, I've got an angle here, an angle here, an angle here, and this 162-degree angle. So now that I can see that I have these two parallel lines up here, and they are cut by this transversal, which really doesn't have a name, but I guess I could call this transversal here transversal T. I can compare some of these angles. For example, I could take a look at angle 1 and the 162-degree angle. Those are same side interior angles. And anytime we have same side interior angles, we are dealing with a pair of supplementary angles. That's something we know about parallel lines cut by a transversal. So I can investigate this and just say that the measure of angle 1 is going to be equal to, the measure of angle 1 plus 162 is equal to 180. All right, and then I can subtract here, and I get 18 degrees. So I know that the measure of angle 1 is 18. Now I just have to do something similar and find the measure of angle 3. If we take a look over here to the two angles dealing with this 98-degree angle and angle 3, that's also going to be a pair of same side interior angles because I have two parallel lines cut by a transversal. So I can do the same thing there. I can say the measure of angle 3 plus 98 is equal to 180. Great. And so I'm then able to subtract those. The measure of angle 3 is going to be equal to 82. And so now I know the measures of angle 3 and angle 1. So if I go back to trying to calculate the measure of angle H, all I have to do is add 18 to 88, which is 100. So H should have a measure of 100 degrees. Correct. All right, let's do one more, and we'll go to one of the more challenging ones here. All right, let's take a look at this one and solve for P. And this will be the last one we'll do here. So in this diagram, I have two sets of parallel lines. And I've got these two lines here are parallel. I know that because of those two hash marks, the two arrows on each of them. And then these lines here are parallel because they have one hash mark each. So I have to be careful about deciding which line is parallel with which line. Now what I'm going to do is just sort of highlight these double hash mark lines because those are parallel. And I'm going to block out everything except for those two parallel lines and this transversal, which is going to allow me to see that angle 68 can be transplanted to a lot of locations in this angle here based on what we know about angle pairs. For example, I could say that this has a measure of angle 68 because they're corresponding angles. Or I could say now that this has a measure of 68 degrees because that's a vertical angle with this 68-degree angle. So figuring out that that angle there has a measure of 68 is pretty helpful because I know that a straight line, this straight line here, has a measure of 180 degrees. So if I were to draw in an arc that equals 180 degrees, I now know that part of that arc is 94 degrees and part of that arc is 68 degrees. So I can say that 94 plus 68 plus whatever the measure of angle P is equal to 180. All right, and this is where I'm going to do some addition and then eventually subtract. So what I end up coming up with here is that the measure of angle P is equivalent to, no, that's not right. Sorry, that's Q. The measure of angle P is going to have to be equivalent to 18. Right, 68 plus 94, there we go, 162, yeah, 180. So the measure of angle P has to be 18 degrees. And there we go. All right, so that's just some of the ones that were most missed. If you've got questions and you want to set up a meeting with me to go over some of the other ones, that's fine. Let me know.